Let's go ahead and take the derivative of this function, the square root of x, using the limit definition. Remember that our limit definition is the limit as h approaches 0 of f of x plus h minus f of x all over h. So here our function is the square root function, and we're just going to plug it right in. So we've got the limit as h approaches 0. F of x plus h, well, that's our function, the square root function, but it's not just evaluated at x, it's evaluated at x plus h. Notice the function composition here. Don't just say the square root of x plus h. That would be a common mistake. It's x plus h composed inside. Then we subtract original f of x, which is the square root function. This is all over h. And what we have here is a limit problem to solve. You'd notice if we try to directly substitute h equals 0, well, we'd get the indeterminate form 0 over 0. So what limit technique would work here? I see square roots. You should think multiply by the conjugate. So let's do just that. The conjugate of root x plus h minus root x is root x plus h plus root x. And I can't just multiply by that, I have to multiply by that over itself. That way I'm multiplying by 1. Okay, in the numerator here we have that difference of squares formula. So all we have to do after we write limit as h goes to 0, we just square the first term. Root x plus h squared is x plus h, minus square the second term. Root x squared is just x. And in the denominator, I'm just gonna mash this together. I'm not going to distribute. You usually don't distribute that non-conjugated term. Well, look at that. Those x's, those are just going to go ahead and cancel out. X minus x goes away. So that's nice. Limit as h goes to 0. And now we're going to be able to cancel that h in the denominator, that problematic factor of h. Because I have that h over h, those will cancel out. And once we cancel that h, we're just going to be able to plug in h equals 0. So I'll write this one more time. Limit as h goes to 0. Now it's 1 over root x plus h plus root x. If I plug in h equals 0 here, there's only one h. This would be 1 over root x plus root x. Combine like terms here. We're going to get the derivative to be 1 over 2 square root of x.